Okay, good morning. Welcome to
SuperMath number 29.
SuperMath29. So today we spent a long time, right?
Yep.
On this problem from the 1990 AMC8 number 25. And it said how many different patterns can be made by shading exactly 2 of the squares in a 3x3 grid, with the restriction that patterns that can be made the same by rotation or flips are not to be considered different. So they gave an example that I think looked like this, where they rotated. They said this, 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 and that are to be considered the same. Okay, so we're going to take a 3x3 square, we're going to shade 2 of the squares, and anytime the flips or rotations we do, those are all to be considered the same. So the question is, how many different patterns can be made? This is actually a really cool problem. This is from a combinatorics subject called the Polya theory of counting. And you can count some really neat things. You can, for example, count on a Rubik's Cube. How many different positions are there on a Rubik's Cube where something like this, or that, and that, and that are all considered the same?
There was a lot, I remember.
Yeah, yeah, good answer. A lot. But we're going to do a simpler problem. We're going to do this one. So we've actually made these off to the side as part of our solving of this problem. But what's a good approach to this problem? How should you start thinking about it? Or what's not how should you, but what's one way to start thinking about it?
I'm going to start by finding all the squares that have the center shaded.
Okay.
So we have that one and that one.
All right. Very good. What can you do once you shade the center?
Well, you can either have an edge for your second square, or there's going to be edges or corners.
Okay, so let's pick the corner one. Once you pick a corner, what's that mean? How many different ways can you pick that corner?
Well, 4. 1, 2, 3, 4.
And what's special about those 4 arrangements?
They're all different.
Well,
they're all the same.
They're all the same by rotation.
Yeah.
And flips. Okay. And the same thing ends up being true when you pick the middle or the center. I'll call it the center plus a middle. Okay. There's only all of those arrangements end up being the same. Okay. So now that we've identified picking the middle, we found 2 arrangements now. Okay, what can you do next?
Well, now let's choose just corners.
Just corners. Okay. What can happen when you choose just corners?
Well, you can have the corners that be like this, where they're opposite, or you can have them be across.
Okay. So I'll call this adjacent. I would actually probably use the word opposite for these. Adjacent, so they're next to each other, or they're opposite each other. Okay, so what about these situations?
Well, it looks like these 2 would be the only ones.
Okay, how come?
Because there's no, you can't put this corner anywhere else. If it's here, it's adjacent as well.
Okay, show me how you can change this situation into the situation you're describing. Just rotate. Yeah. Or do a diagonal flip. See that?
Yep, and if it's...
But can you turn this situation into that situation?
Nope.
Nope.
So there's only going to be these 2.
Okay, great. So that's 2 corners together. What's next?
So now let's do just edges.
Just middles.
Yeah, just middles.
Okay. Tell me about the 2 middle situation.
So it's going to sort of work in the same way as the corner. We have these 2 ones that are just touching, and these ones that aren't touching.
Okay. So these are adjacent and opposite. Just like the corners.
So you can't turn this one into that one.
Not by rotating, no way.
No, not by flipping either, because these aren't even touching.
Because they're not touching. Very good.
So these are 2 separate ones.
All right, show me how to turn this situation into, say, this situation over here, where these ones are.
You can do a diagonal flip.
Do a diagonal flip, for example. Okay, great. So far we've found 6 different arrangements. Is that all of them?
There's going to be a corner edge.
Ah.
And corner one edge.
corner edge. These are the most difficult ones because it's hard to see that these are the only ones. But how would you think about these situations?
Well, you can see that they don't turn into each other.
Okay, how come?
Because these are touching.
Right,
These
touching
aren't.
versus not touching. Rotating doesn't turn touching into non-touching. And flipping doesn't turn touching into non-touching. Okay? But the challenge on this one is to turn this into, say, this. So the two touching edges are over here instead of over here. How do you do that?
Well, you can.
The flip gets it for you. Okay. All right, well, very good. So we built all of them. And now for what also turned out to be kind of a difficult question. If you're going to pick two squares to shade in black on the square, how many choices do you have?
Well, you have 9 choices on the square.
All right.
Times 8 choices for all the other squares,
Alright.
minus the one you chose.
Yeah.
So it's going to be 72, but we overcounted something. Like, say we had this situation.
Okay.
So, and our first one was here,
Yeah. So I picked this square
then that square.
and that square.
It'll be the same as picking that square, then this square.
Okay. So I count this situation twice when I do that 9 times 8. So how many are there actually?
There's actually 36.
It's actually 36 total, and they can be divided into these
8 groups.
8 groups. Okay. Good job. Good job, sweetie.